Hi, welcome to everyone. My name is Kota Shanmugam from Artificial Intelligence and Data Science in Johnson's Institute of Technology. Synthetic fuel and overview. Synthetic fuel. Synthetic fuel or synfuel is a liquid fuel or sometimes gaseous fuel obtained from either syngas, a mixture of carbon monoxide and hydrogen, or a mixture of carbon dioxide and hydrogen. The syngas could be derived from gasification of solid feedstocks such as coal or biomass or by reforming of natural gas. Alternatively, a mixture of carbon dioxide from the atmosphere and green hydrogen could be used for an almost climate neutral production of synthetic fuels. Synthetic fuel manufacture and properties. To manufacture synthetic fuels, hydrogenation of the naturally occurring raw materials or carbon removal is usually required. Since common fuels such as gasoline and natural gas have a higher hydrogen content than the raw materials, the source of the hydrogen that is added is water. A typical bituminous coal has a carbon to hydrogen mass ratio of about 15, while methane, which is the principal constituent of natural gas, has a carbon to hydrogen mass ratio of 3. In between, the corresponding ratio for crude oil is about 9, and that for gasoline is 6. The organic material in both tar sands and high-grade oil shale has a carbon to hydrogen mass ratio of about 8, which is close to that of crude oil. However, the mineral content of rich tar sands in the form of sand or sandstone is about 85% mass, and that of high-grade oil shale in the form of sedimentary rock is about the same. Therefore, very large volumes of solids must be handled to recover relatively small quantities of organic matter from oil shale and tar sands. On the other hand, the mineral content of coal is the United States average about 10% by mass. In any conversion to produce a fuel of a lower carbon to hydrogen ratio, the hydrogenation of the raw fossil fuel may be direct, indirect, or by pyrolysis, either alone or in combination. Direct hydrogenation involves exposing the raw material to hydrogen at a high pressure. Indirect hydrogenation involves reacting the raw material with steam with the hydrogen generated within the system. In pyrolysis, the carbon content is reduced by heating the raw hydrocarbon until it thermally decomposes, distilling of the volatile components to yield solid carbon together with gases and liquids having higher fractions of hydrogen than the original material. Fuels that will burn cleanly require that sulfur and nitrogen compounds be removed from the gaseous, liquid and solid products. As a result of the hydrogenation process, sulfur and nitrogen, which are always present to same degree in the original raw fossil fuel, are reduced to hydrogen sulfide and ammonia respectively. Hydrogen sulfide and ammonia are present in the gas made from coal or released during the pyrolysis of oil shale and tar sands, and also are present in the gas generated in the hydrotreatment of pyrolysis oils and synthetic crude oils. Advantages. In many ways, synthetic fuels are cleaner than petroleum fuels. The heavier metal and sulfur contaminants of petroleum fuels can be captured in the synthetic plants before the fuel is shipped out. Synthetic fuels also can be used in gasoline and diesel engines with no need for modifications, unlike many biofuels. Disadvantages: high gas yield, high hydrogen consumption, and limitation of oil usage only as a boiler oil because of impurities. Properties: synthetic diesel fuels are characterized by excellent properties such as very high cetane number and no sulfur content. They can be used in existing diesel engines without modifications or mixed with petrol diesel. It may be used as a fuel gas as a source of hydrogen for direct liquefaction or for the synthesis of methanol and other liquid fuels. Synthetic carbon neutral fuels capture CO2 in the manufacturing process. In this way, the greenhouse gas becomes a raw material from which gasoline, diesel, and substitute natural gas can be produced with the help of electricity from the renewable resources or sources. Thank you.